Okay, good evening, everyone. So I'm excited for this. I've got a command-based programming system for my Arduino that I've coded up. So the idea behind this is kind of like borrowed from the FRC command-based programming. They've got a system where you kind of just schedule commands and they just kind of happen. And it takes care of figuring out when things should run and how. And so I've decided I want to reproduce that for my Arduino here. So it's going to be a lot of coding this time, and I'm going to be just making a lot of, just showing you the code and how it works, and but a lot of interfacing with the code, the Arduino, by using the this serial port interface. And John, it's great that you made it this time. Thank you for watching. So I'm really excited because this is kind of going to be like a really simplified way that you can of looking at this command-based programming. So here's what I'm going to do. I'm going to start off by finding my template here. So start off with a basic Arduino Sketch, and I'm going to write down some things that I want to do here. So I want to, let's see, I want to go and have a way to like say what the current running command is, and that's going to allow me to keep my programming or this thing like focused on the same task across loop events. So then I'm also going to like do a lot of create actually a couple commands here. Like first, also I'm going to create like a kind of an echo command. So let's get started on that. So I'm going to create a place to store the current command. That's going to be right here. All my commands are just going to be single characters. So it's going to be very simple. We're not going to be tracking anything crazy. So characters are of course a char, whatever. Variable type, and I'm going to call it current command. And I don't like to have variables that don't have a default value. That can cause some really bad programming bugs, so I'm going to say the default value is the null character. If you've never seen this before, this is basically the character equivalent of 0. It doesn't print, it just is null. So let's also start with a serial interface. In our setup, we'll set up our serial interface because that's how I'm going to be interfacing with this thing pretty much the whole time. Serial interface on my computer side is right over here on COM port 8, and that's how I'm going to be communicating with it. Now here I want to I still got to, after I set up things, I still need to loop through all of my main code. But as I do that, I want to do two things. I want to output to the serial port that what my current command is, and I'll do it this way. So the top command will print out current command, and the bottom one will add to that line the actual value of the current command. Pretty straightforward. And then I also want to add a little delay, because this will run as fast as you can. So I'm going to add a delay like this. So pretty simple so far. We've got a place to record the current command. We've got a place to set up the serial port, place to display the current command, and a delay. So I can run that real quick, and you can see what the result is. So yeah, I'm really excited about this. I love this kind of programming. Who doesn't want to create their own like operating system? So you see, current command is the same every single time. So let's see, so let's create a few commands here. I think we need some way to, well, we've got an echo command. Let's make an echo command. The idea is that I'm just going to take whatever you type in here and whatever you send over the serial port and echo it back to you. So I'm going to do an echo command here. Let's see. So basically the idea is that, let's see, if the current command is E, then do a bunch of stuff. Now, you may have noticed I put this this E here over to on the left side. This is like a programming trick, because what if you accidentally do a single equals? That's actually trying to set what's on the left side to whatever's on the right side. If these were swapped like this, I would actually be setting current command to E, and this statement would always be true. So that's kind of a quick way to. But if I had the code like this, this doesn't compile. This tells you this is garbage, because you can't possibly set a constant to a variable, and it will just simply not compile like this. Oh, it's garbage, right? So it's an easy way to pick up on some programming problems. So let's see. My echo command is basically going to say, find out if there's input available from the serial port, serial.available, and this tells you how many characters. If there's more than 0 characters available, then do the stuff here. And I'm going to say, input available. Do a little comment here. So if there's an input, I'm going to get that as get up a temporary variable here. I'm going to just call it input, and get that using serial.read. This normally returns an integer. I'm turning it into a character. Just pretty straightforward. Now, what's funny though is that let me code this up for you, and then I'll show you one weird quirk about this. So here I'm going to print out what I actually got, and I'm going to use serial.print to say I got the value, and then use serial.println to just display the value, and also this println version of this command, of this method, adds a new line, so it will put it on a new line in the output window, kind of just like current command here. So it'll output the value, and that's it. So let's also, in order to make this work, let me also set the command let me set a default command. And the idea with the default command here is like, if current command is, I don't know, actually I want to do it up here. If there's no valid command, I want it to reset to a default command so I don't lose control. And so I'm going to do that down here. Say if the current command is not an E, then let's make the command E. So I'll do that. Make it the echo command. So this loop is going to run. It's going to say, oh, the current command is not any of these things, so I'm just going to set it to E. So let's try this. Clear the output just so you could see. See, it got stored. And now here's my current command. It saw there was no command, so it set the current command to the E, the echo command. So let me show you the quirk of this. The quirk of this thing is that when you send something over this line, it wants to actually send a new line character as well. So by me pressing, say, F here and hitting enter, it's actually going to send 2 values. So it'll say it got this F value and another value, which is actually a new line. I can change this to not add a line ending, but it's actually, for me, it's just easier to make it ignore line ending. So let me type in a B here. With the no line ending setting, it does not send a new line. But in this case, I'm just going to leave it because oftentimes I'll forget. I don't just want to deal with it. But if I say that, you can see every character I typed gets sent, and then it gets echoed back to me. So that's basically this echo command. So I got my Arduino running and responding to an echo command. So what's the point of this? Well, this is a robot. So I'm going to do some interesting things. This is kind of annoying. I'm going to do some things with this command-based programming system. You can see the bones of it here, right? So I can set what the currently running command is, and I can change it at any time based on the currently running command, and I can do different things. So what I'm going to start doing is adding other commands to this, so I can like get this to say drive forward, drive to the side, do different things like that. But let me go and do that thing to ignore those other new line characters. So I'll just do this. So if the input is, so I want to only display that or echo that value back if it's not a new line or not a carriage return, because Windows likes carriage returns. So that's my program so far. So let's create another command. This is going to be like a command to get commands from here. Right now this just echoes. Well, I want it to do more than just echo. I want to control the robot or control my Arduino through this console, this communications port. So I'm going to take this existing echo command and I'm going to duplicate it, just copy and paste. Yeah, let me get rid of this comment. Say otherwise if, and create a command called S. And the idea here is it's going to take input from the serial port, and I'm going to make the current command just whatever the user typed in, whatever I typed in. No, I don't want it here. I want to ignore, because new lines and carriage returns are not commands. So if it got something value, or it got some value, I'm going to change it to got command. Say if it got a command, I'm going to change the command to that. And now I don't have to have the default command be E. I can make it S, and it can kind of be like my command that runs other commands. So in my echo command, I'm gonna only run it once. I changed my mind. I'm gonna have it just run once. It's gonna get one character, echo it back, and then it's going to clear out what the current command is, and so it'll go back to what the default command is. And I'll show you how this works. Let's go and compile and upload it. Clear my output here. And current command starts off as nothing, then becomes S. And because it's S, it's my serial port whatever command. I'm going to say I want to do the echo command. And now the current command is the E echo command. Now I can type in a character like H, and turn back on auto scroll here. And it's H, and it'll echo the value H to me. And then the echo command will bail out, and we return back to the serial command. So now I've got a way to control the robot to run other commands just by adding this serial port command. So that's kind of the idea so far, is I really want to utilize this command-based programming. Now, it really can get really deep. The FRC one lets me do all kinds of crazy stuff, but I got to build up to it because I got nothing. So let me start building up towards this. Let me make I'm not actually going to drive the robot, but I'm going to pretend I'm driving the robot. I'm going to make a kind of drive forward and a drive backwards command, just for the heck of it. They're not really going to drive forward and backwards. They're really just going to just display on the console that they're driving forwards and backwards. So let me start here. I'm going to add another conditional here saying else if the F is the current command, and then I'm going to, let's see, I want to actually make this command last longer than just say, you know, the cycle of a loop, right? I could just do this. I could just say serial.println, you know, moving forward, and then cancel out, right? All I'd have to do to cancel out is say the current command is now the null command, the null character. I could do that, but that's not really the advantage of doing this command-based programming. The real advantage is being able to keep the command going across runs of this loop. So let me show you how it's working now, right? So we ran the F command, and we come back to say it's moving forward, and we come back to no command at all, which returns us back to the default S command. So what I really want to do is I want to get sophisticated. I want to do something like this. I want to record when I started this and have it automatically cancel itself after, say, 5 seconds. So I'm going to do that by going back up to the top here and setting up another variable. I'm going to do it to record a time. Time in Arduino, at least the millisecond time, is recorded as an unsigned long integer. So it's going to be an unsigned long. I'm going to call it drive start time, and it's going to be 0 by default. So that'll let us remember when we started driving. So then, to go and figure out what to do, I'm going to add a if statement here saying let's see. We want to figure out if we're starting, right? So if I'm going to add this comment here. If drive start time is 0, then we're starting the drive forward command. So let's do some stuff you might do when you're starting to drive forward. In this case, I'm just going to print out something, but I'm just going to add this condition right here. If 0 equals drive start time, then let's record the actual time. And then I'm going to print out to the console that we're starting to move forward and recording the start time that we started moving forward. And then what I can do is then let's see. Say if we didn't just start off. So otherwise, we want to be moving forward for. I just want to show how long I've been moving forward, or how long I will be moving forward. In this case, 5,000 milliseconds is 5 seconds. So I'm going to display, a countdown to when I run out of time. And then I also want to go and have some cutoff saying if we run out of time, I want to end this command. So what I'm going to do is instead of ending the command here, I'm going to end it up here. So let's add this conditional saying we got to calculate how long we've been moving. So we take the current time and subtract out the start time. And if that's been more than 5 seconds, or 5,000 milliseconds, then we need to go and end this command. And I can do that by saying, well, I'm going to do it this way, because I had some code pre-written. So I'm going to log to the console saying that we're stopping forward movement, we're resetting the drive time, and we're clearing out the current command. So you see that we're clearing out the current command, and the drive time is being reset. Now we don't need this code anymore. That was what it was making it do stuff before. So I got a kind of a pretty sophisticated little command here, right? It's got kind of a start, a middle. So this is a start, a middle, and an end. And now it's going to run across loops here, right? It's not going to cancel itself immediately. So once it gets scheduled, it's going to say, oh, well, am I actually starting? If it's starting, it's going to record the drive time. And if it was a real robot, you would start actually moving forward, right? So then it's going to say, well, if the if it's been more than 5 seconds, we're going to stop movement. We're going to reset and we're going to clear out the current command so we can do something else. And then if we're, it's just, and something in between, this is like if the loop runs in between the start and the stop, this is when it's going to display. And I'm actually going to do something else different in this middle part because I want to do something interesting. But let's see what this does so far. Clear out my output here. All right, back in control. It's we've got this set up here, and I'm going to say I want to run the forward command. So we got the command. It's starting to move forward, and then you see it's got this kind of countdown until the command ends. So let's take a closer look at this. So we're starting to move forward. That's what's happening here. And the command keeps going. So then it calculates that, oh, I've got less than 4,000 milliseconds to go, but it's continuing to move forward. Still have the command. Now it's less than 3,000, less than 2,000, less than 1,000. And then once it's done, once we've run out of time, it's going to stop. It's going to reset the drive time and clear out the current command. So you can see this is a great way to control like how long something is running. So I'm going to keep doing this. In fact, one of the things I did with my IR control code is that I had it kind of ramp up the power. So let's kind of simulate that. So I'm going to add a variable here that represents the amount of power we want to send to it. And so I'm going to do that with an integer, int, and call it drive power. I'm going to set it to 0. So power is initially 0. I mean, not like I said, no actual power is happening here. But what I'm going to do is at the start, I'm going to set it initially to drive power equals 150, kind of like I did with the IR code. And then I'm going to put that out to the console here. Then I'm going to, kind of what I was doing with the infrared robot, infrared control, I was like ramping up the power. So I can do something here. This is, remember, that code that's running in between the start and the end. So I'm going to start controlling something here by getting it to ramp up power based on how long it's been running. So I'm going to say if the amount of time, the current milliseconds minus the drive start time, if that was more than 2 seconds, I want the power to actually be 255. And if it was only, say, if it was only like 1,000 milliseconds, then I actually want the power to be a little bit lower than that. I want it to be 200, let's say. And I want to display what the power looks like. So there we go. So what I just did here is I started off at 150 power and displayed that, and then said, okay, after 2 seconds, I want it to be at full power, 255, and after 1 second, I want it to be 200, and I just want to display what my current power level is. So let's see how that works. Okay, let's clear my output here. And then start my command. Turn off auto scroll so we can see this better. And you can see that drive power started up. And so we started the drive forward command, started at drive power of 150. After 1 second, it ramped up the power to 200. After 2 seconds, it ramped up the power to 255, and then kept it there, and then stopped the command. So this, I'm really excited about the way this works, because I think this is really a cool way to control the robot. So let's see. I think that's kind of the basic concept. So I think what I'm going to do next now is get a little bit more advanced. What I'm going to do next is I want to give you another way. Let's see. Let's say, let's get a bit more sophisticated. I want to be able to run more than one command at a time. And you may be thinking to yourself, how do you do this? Well, computers do this all the time. Computers are great at multitasking in a way that humans really are not. So what they can do is quickly change between tasks. These commands, in this case, represent tasks. But right now, my program only has a way to track one command. So what I want to do is track multiple commands. The way I'm going to track multiple commands is I'm going to change this array, or this character variable current command, to an array, and do a number of different changes with that. So what I'm going to do is change the way you make an array is, well, first you got to have a length. So I'm going to define do a define here that's going to be max current command array length. And I'm going to say, well, we want to be able to run up to 10 commands at the same time. So let's do that. So that's my length, and then I'm going to change this to be a character array. Now this doesn't, and I'm going to get rid of this initialization. Now this doesn't really make sense, so I'm going to change the name to current command array. Now it's really like, this is the max length, but at the start of the program, there's actually going to be nothing in the array. So I need a variable that represents that there's nothing in the array. So I'm going to do that by creating an integer variable, and I'm going to call it current command array length. And I'm going to start it off at 0. So that will allow us to track all the current commands and how many they are. I'm going to comment this guy here. Time when we started driving. So, like, how do we start going and making this all work? Well, obviously, now that we changed some variable names, this is not going to compile. So this is kind of like we're starting to figure out how to refactor our code. Basically, the idea is we're going to make it do something better. So we're going to break it so we can make it better. So the first part is, well, obviously I can't print out the current command anymore. But because Arduino, a character array is basically a string, it's actually really easy to send this whole string of commands back to the serial port. And I'll do that using serial.write instead. I'm going to call this, instead of current command, current commands. And like I said, instead of serial.println, I'm going to use serial.write. And now this is going to use a slightly different syntax. Basically, the idea is this is a buffer. So it's going to take a buffer, which is the current command array, and it's going to need the length. So that's going to be the current command array length. So it's going to just read this many characters, and which is at the start is going to be 0, but that's exactly what we want. And then I'm going to add a new line by using println. So then we've got, now our current command variable is completely gone. It doesn't exist anymore. And I try and compile it again, and you see it doesn't exist. So how do we process commands? Well, we're going to loop over every single character command in this array. And the way we're going to do it is we're going to use a simple for loop. And you may be familiar with this, you may not. The idea here is you start at a value, and then you do something to say whether you need to continue or you need to stop, and then you need to change the value. And those are in this parentheses, those 3 statements are in these parentheses. So initially, I'm going to start at the end of the array, actually. I'm going to create kind of an index variable to represent where we are in the array. So what I'm going to do is I'm going to say current command index equals the array length minus 1. So I'm starting at the end of the array. So the length of the array, say it starts at 5. Well, it's the index of the last value in the array is that minus 1. So we're going to start at index value, say 4, if there's 5 items in the array. In this case, we also want to make sure that our current command index is always greater than 0, or greater than or equal to 0, since you can't have an index less than 0. Well, you can, but it's going to cause some real bad bugs in your program. And then we're going to start, because we're going from biggest to smallest, we're going to take the current command index and we're going to reduce it by 1 every single time. And that's what this double minus does. So let's throw our code into here. And we basically want to take all of the existing command processing code and throw it in there. So let's do that. And then we'll add some nice indentation just to keep our code visually organized. So now it still is not going to work because current command is still not defined. But now we've got an easy way to figure out what the current command is, and which is just to pull it out of the array. So we're going to say the character code representing the current command. We could just pull that from the current command array using the current command index. Easy peasy now. So now we'll start, say, like if we have 5 commands, it'll just pull the command at index 4 and make it the current command. So now we've got a good definition for current command again, and at least more of the code will compile. Actually, all of it compiled. That's great. So now we've got a good way to run multiple commands at the same time. So let's try this. So let's see, clear the output. And we've got our good old, okay, no commands. Oh, well, because our default command is inside the loop, we have nothing going on because there's no current commands. So we've lost control of our Arduino. All right, let's say this. Let's take our default command setting code out of the loop. Put it down here. And make an if and say if there are no commands, the current command array length equals 0, then let's make a default command. I think that one will work. Oh, I verified it. Oh, of course, I need to add it to the array. So let's do that. Let's say give me 1 second, I'll figure out how to add it to the array. So I want to do this. I want to take the array, the current command array, and put it at the next next available spot, which is going to be current command array length. And I'm going to set that to S. And then because I've added something to the array, I need to add one more to the length of the array. So now we've got that. So let's try that. All right, and we're back in control. So let's try and add a command. Let's do an E for echo. That didn't work. Oh, of course it didn't work because it was setting current command, which is no longer the right way to set or clear out the command. So in this case, I need to, just like I added the S command down here, I need to do something similar up here. So this is the wrong code. This will work though. And then similarly here, I need to clear out this command. Now this is actually a bit more complicated because you have to take basically your whatever index, like it could be any command that decides to cancel itself. So you have to go and shorten the array. And what if you say had like A, B, C, D, E, and say C wanted to, we wanted to get rid of C? How would you do it? Well, I think the easiest way to do it is actually to shorten the array by keeping it at A and B, and moving D from the end to where C was, and moving E from the end to where C was, and keeping D, and then we've shortened the array to only 4. So I'm going to do that here. I'm going to take the, instead of doing this, I'm going to use the current command array, and I'm going to say the, what's my index here? The current command index, so I'm going to set the value at the current command index to the value at the end of the array. So the value at the end of the array is just the current command array length minus 1. So that's the index at the end of the array. And then I can then shorten the length of the array because I've safely taken the command that's at the end and moved it to the current spot. So I can shorten the array now. Okay, so, and then get rid of this one. So this should work now. So we're back at the S command. Let's hit E. Now we're at our, what did I do wrong here? Oh, because it was just an S. So let's, it was supposed to be the input here. There we go. Let's try that again. All right, so now you see we have both the S and the E commands running. So let's type something in. Let's see, I'm gonna make it an F or something. And then you see our echo command said it got the value F, just like I wanted it to. And then we return to the S command. So it's like they're both running at the same time. Now, they're not really running at the same time. They're running right one after each other, right? It's running the E command and then the S command because I'm going from back to front. But you know what? We humans don't really notice. I mean, this is running in milliseconds or microseconds, very quickly. So you don't have to worry about, is a human going to notice? So this is how you kind of emulate things actually literally happening at the same time. So let's do that again. Actually, I can add multiple commands. There we go. Oh, now I'm populating it with a bunch of commands. Look at that. But I think I've actually got a bug here because you see here. Let's see. Oh no, that's it. There's a problem because you see, I'm starting to get these crazy characters. Yeah, so actually what the problem is that I only allocated 10 room for 10 commands, and I just input more than 10 commands. That's bad programming. That will cause all kinds of issues and security issues if you've got something that you put out on the internet. So I'm going to add a little if statement here to say that we're going to check this. I'm going to say if, let's see, if the current command array length is greater than or equal to the, the max current command array length, then I want to let's see. No, I only want to add a command if it's less than the max length. And if it's greater than the max length, I'll come down to this else, and I'll say, oh, there's too many commands. Where's it? Let's see, where's my value here? Here we go. I'm going to tell the person adding commands, can't add the command because the array is full. Because you screwed up. And I'll show you what happens. So let's try to add a bunch of commands, way more than 10. Getting there. Oh, can't add command because the array is full. And this will preserve our program so it doesn't blow up on us. Great. Okay, so that's let's see, that's a lot of what I was trying to do here. Then, and I think now one of the things about this is that I've kind of duplicated some code. You've got some code down here to add the default command, which is very similar to the code up here to add just any command. So what I'm going to do is I'm going to do a little bit more refactoring. I'm going to take this code and put it in its own function. So I'm going to copy this, and I'm going to go up here, and I'm going to add a function here called void add command. And then its first parameter is actually going to be the character representing the command. I'm going to paste that code here, fix the indentation a little. And then instead of input, I'm going to use the parameter. And now I've got a way to simplify my code in a bunch of different spots. So anytime I want to add a command, I can use this function. So I'm going to use that in two places here. I'm going to use it where in the S command, where I try to add a command. So I'm going to take these, what is it, 7 lines, and instead of all this junk, I'm going to just do add command input. Doesn't that make the code so much easier to read? Of course, it would help if I did that. And then go down here and do something similar. So change my default command adding code to just add S. Doesn't that make it so much easier to read? You know exactly what it's doing. If the command array length is nothing, then add the command. Isn't that great? And I want to do something similar for the clearing out the current command. So what I can do is say, give me the index, and let's remove whatever's at the command index. So here's the, so let's create another one. I'm going to call it void remove command. And it's going to take a command index. And then I'm going to reuse the code from down here and paste it up here. And maybe I'll even use, yeah, let's see, command index. Do some variable renaming, fix some indentation. And now I've got a nice new method that I can use back down here. Was it here? No, yeah. So where he can remove himself, and I was at the current index. There we go. That makes it much easier to read and much clearer what it's supposed to be doing. So let's see. So that's the start of this command-based programming. So this is very similar to some of what you're going to be doing if you do, say, FRC programming. So what they're going to be doing is say, hey, every time you hit this button, you want the program, or you want your program to do, I don't know, drive forward, something like that. This is the way that system is set up. So if you've got a currently running command, it's going to just keep running that, based on how you set it up. And next time, I'm going to make this a bit more sophisticated. This is like the bones of a system where you can really really and truly run multiple commands at the same time and have them not conflict with each other, and then have a way to schedule commands so that you can create an autonomous mode just by creating these commands. So I really want to thank you for watching, and I think this is really exciting to me. So have a great night, and thank you.